So if you write a program, actually there are some, I would say, standard way or the best practice of how to approach a programming exercise. And today's contents are based on the link here. So this link here is, I remember, is a tutorial from another university, but I think this tutorial is really nice. It's from the University of Birmingham. Yeah, oh, wait, okay, this link is a bit, yeah, they changed the link. Never mind, we have all the contents in my slide. Okay, but again, you can find a lot of good tutorial online to teach you about how to write code in a more efficient way. And here I just want to share some basic ideas with you guys, because programming is not just type the code itself. The programming is actually the entire process about problem solving. So it's really important to know all the entire process. So we only write the actual code, we only programming in this step. But this step is probably the least important step. It's the step that is not as important as we think about. So I will talk about why, and I will talk about something that can help you to improve your programming skill. So actually, when we want to solve a real world problem by programming, we can divide the step into these 4 steps here. We can divide the process into these 4 steps. The first one is identify the problem. The second is design our solution. And the third one is to write the program based on the solution we design. Finally, we need to check out whether the solution works or not. So let's start from the first step here, identify the problem. So actually, in this course, we don't really need to identify the problem. And the reason is that in this course, for the programming exercise you can get, the TA and I actually help you to identify the problems, because you have a really clear description and really clear description about what is the output, what is the input and output, right? So you don't really need to identify the problem by yourself. However, I will say for the final projects, you need to identify the problem by yourself. You need to identify what kind of things you want to implement by yourself. So you will still practice this step in this course. And also this step, it can reflect what happened in the real world. And it can reflect what happens if you want to get a job, you want to get an internship in the IT industry. Because for the most of the time, identify the actual problem is hard, and we need to identify the problem by ourselves. And the reason why it's hard is because real world is a chaotic place. And the real world problem will not let you know what is the range of the input variable. You need to define them by yourself. So this is the first step about identity the problem here. So in this course, actually what we need to do is identify the solution. So to identify the solution, the first step is that we need to know the requirement, right? So if you don't have a clear idea about what is the requirements in this code and you just start writing your code, there's a high chance that you don't meet the requirements at all. So this is also the important thing, please remember during the midterm exam. Please make sure you have a full understanding about the requirements of the questions in the midterm exam. Because if you fail the requirements, then you might continuously get the error feedback by don't judge, and you don't know why, because maybe you just forgot to meet one certain requirement. So that is the first important things. And also, if we ask you to write down a more complex program, like a calculator program, can you identify these requirements by yourself? And the second step is that after you have a clear understanding about the requirements, the next step is you need to come up with the specifications. So the specifications, what it can help us to do is to decide exactly what your solutions, what your program should do to fulfill the requirement. Because usually there are different solutions for the same programs. You can achieve the same output by different paths. However, it is the programmer's job to decide which of these solution you want. And also the specification is also the original meaning of the spec. So I believe most of you can heard about Kai spec, right? Spec, 文件, spec, documentations. So the word spec is actually come from the specification here. So spec means that you have a really detailed requirements about the thing you want to implement. And you will read this spec document a lot in the real job, in the IT industry. So it's really important to have a clear specifications. And I will encourage you to list the spec by yourself for your final project, so you have a better understanding about how many things you need to do, and you have a better understanding about if you have enough time to finish all the things you want to do. So the second step is design a solution. So after we have the spec, then we need to turn the spec into a working program. So programs basically a list of the steps, and the list of the steps will tell computer what kind of things the computer should do. So when we design the solution, what we do is to design what is this list of the steps, and we need to make sure this list of the steps can meet the specification we have. So how to design the solution after we have a clear understanding of our requirements and specifications. So the thing we need to do is not writing your code. Actually, the first thing you need to do is pick up your pen and paper and draw the blueprint of your programs. So blueprint is the design sketch like this. The Chinese called 蓝图. So for example, you can use a pseudocode or flowchart like these two things to draw the blueprint. So you have clear understanding about all the process and step and the function you want to use in your blueprint. And once you complete your design on the pen and paper, now you should have a very clear idea about how the computer or how your code is going to fulfill your specifications. So here is just some example about the blueprint for the program here. You can write down the step one by one. You can also use some diagrams to help you to draw your solutions and idea. And here is the example of the pseudocode here. So pseudocode is closer to the actual program you will write. So I will recommend you can write down pseudocode. And also flowchart is also an important tool to help the programmer to display the entire workflow of your code. So I will recommend you can try to write down this thing or draw this diagram by yourself. So that is all about the design solution. So after the second step, now you should have a really clear design blueprint for your code. So the next step is write the program. So all the thing you need to do is based on your blueprint and then translate the design of your blueprint into code. So programming basically is the task of describing your design to computers. You tell the computers your way of solving problems. And actually, when we write the program, there are three stages. We can actually divide the entire process of coding into three stages. The first stage is coding, obviously. So the action, the behavior of coding is to translate the design from blueprint into actual programs. So now if you are going to code, you can sit down or stand up at the computer and start to type. Then after you finish your code or finish the part of your code, then you just press compile. So you can do the compilation here. And the third step, I will guarantee for the over 90% of the time or 99% of the time, what you need to do is debugging. So your program is likely to come back to you with a long list of mistake, error message, and warning message here. So I really like this meme here. So this meme is the everyday life of the programmer. So it means that it is entirely normal to do the debugging. Even for the expert programmers, these people also debug a lot. And I will say the skill of debugging is the essential skill for experts. Yeah. So this means also, I would say, can reflect the real life of the programmers. The movie and TV series describe the programmer like we can type in so fast, and then after we type, we can just get the program run. But for the most of the time, the programmers look like this. We just continue to think about why we have this error here, what the output is here. So we use a lot of time to think about how to fix our code, how to debug. So actually, we also have some best practice for debugging. So debugging is the process of reading error message, and based on what you read, and you try to revise your code. And doing the reading the error message and the original program, all you need to do is try to search, try to identify where is the mistake, and try to identify how can I solve this mistake. So here is the cycle of debugging. First, you need to find the location of the error, and you need to understand why this is wrong. And then you need to try to find out the solution to fix the error. And then you might find out, okay, my solution is not going well. Then you need to find out the error again, and again. So this cycle will often be repeated many times. Yeah, so I also like these names. I found these names yesterday. So the days before OpenAI, we already spent a lot of time debugging. However, if you use vibe coding and you directly use the code generated by generative AI, then you need to spend more time on debugging. So please be very careful about the code generated by AI. You need to make sure you understand each line of it, because that can help you to reduce time of debugging. So here I want to quickly introduce two debugging techniques here. So the most traditional way of debugging technique is called logging. Logging means that I just print every information after every step. So here you can see I just write down the message, debug here, and then I just write down all the important steps in this code, and I just print out the current values in those key variables. So this technique is called logging. And I will say this is a very old-fashioned way, but if you are the beginner, it is the way you can start to try. And the next thing is, the next technique is step-by-step debugging. So if you use the IDE like VS Code, you can set the breakpoint in your code. And by setting the breakpoint, you can see a lot of red dots here. So when you run your code in a debug mode, and if you have a breakpoint in your code will stop at this line. And when it's stopped, you can go to your IDE and check out the current value stored inside the variable, and you can know that whether this value is the value you expected. And I provide a video link here. So video link here, this video will teach you how to set up the breakpoint in the VS Code. So I strongly recommend you check out this video, or you can find the videos in Chinese on YouTube. So the logging is kind of like this. In every step of our code, I just continue to ensure all the important variable is operated successfully. So I just put out the information before every important steps. Okay, so the final step is check the solution. So after I write my programs and I clear all the bugs and I pass the compilers, then I need to check if my programs behave the way that I want it to behave. So the first thing, of course, you need to run your code and you need to try to type the example input or any other input you think about, and you need to check if the output is the output you expect. Okay, so yeah, check the solution is the final step here. Just check all the input message you can think about and try to observe if anything wrong in your output. And if there's anything wrong, go back to your code and debug again. So you can see programmer is, I would say if you want to be the programmer, you have to have enough patience, because you will need to spend a lot of time trying to fix different things. But I will say the people who love programming should also love debugging, because debugging I think is fun. It's kind of like you try to find out who is the criminal in your code. And when you find your bug, that sense of accomplishment, that sense of happiness is beyond everything, I would say. You will have a lot of dopamine in your brain. So yeah, so that is the fun part of programming. And the next thing I want to share about is I found there's a very interesting thing launched by CS 50. So is there anyone heard about the Stanford CS 50? Is there anyone know about it? No? Okay, then I need to introduce it. Okay, this is one of the famous programming course nowadays. So, and this is a free course, and this is taught by Stanford. So if you want to learn what the student from Stanford learn, you just go to CS 50. So here they just provide all the materials they have online, and you can check out the course materials every week. You can check out what kind of the final projects they did. They also have the gallery here. And they also incorporate the generative AI a lot. So the generative AI I want to introduce is this duck here. So let me try to go to this one. This is called CS50 AI, And what this doc can do is to be your learning partners and teachers, and they will collaborate with you to solve your code. However, this collaboration is not like you just ask generative AI and AI can get you an answer about it. This doc AI will guide you to debug your code step by step. So the team of CS50 do a lot of adjustment to this doc AI. And to use this doc, actually you need to log in your GitHub account. So let me try to log in my GitHub account here. Okay. Okay. Hey. Okay, I forgot my password. Let me use my Google account to log in right now. Link. Okay, sorry, I should log in your device. Okay. Okay, let me log into the doc. Okay, so here we have doc here. So this doc will call Quank. I'm the CS50 doc debugger, DDB. And it is experiment AI for rubber ducking. So what is rubber ducking? We can check. You have a Wikipedia here. So actually, rubber duck debugging is one of the debugging technique. It's really cute. So this technique is that a lot of time when you have some error in your code, the first thing you need to do is to explain your code to anyone. And if you can find one friend, if you don't have anyone to explain the code, you can also explain the code to the rubber duck. Then, for the most of the time, after you explain your code, you will find out what's wrong in your code. So this debugging technique is called rubber duck debugging. So this CS50 course make an AI version of rubber ducking. So you can say that my reply are not accurately, so please think critically and let me know what you think. So here we can ask the question about, let me see. And I would say one drawback is that you can only communicate it in English, but I would say this is a good thing to practice English, right? So you can see I just type that I don't understand this code, and this doc actually explain the code here, and then he asked me if I have any specific question about this code. Then maybe I have a question about I don't understand why I need to write the photos in this way. I don't know why I need the photos. Is there any? And yeah, the doc will explain all the things. So because the example I put it right now is not complicated, so it seems the return feedback is the same with the chat GPT. I'm not sure, or any generative AI, but I will encourage you to try to use the CS50 AI docs by yourself. It can have some interesting output. So that is the final debugging tool I want to introduce. Yeah, and that is all for today's course, and thank you for coming.